Hello, my name is Mikara Hurao, and today I'm going to explain problem number 2 of midterm 1. This was the problem I had most difficulty with. This is the problem they give us. It says a tiny object is located at origin, so here in the middle, with a permanent dipole moment of P dipole moment equals P times X hat. Four identical atoms with polarizability of alpha sit at a large distance. D is bigger than S. So from the origin at the compass points north, south, east, west, let K be 1 over 5 pi epsilon. So they gave us this, right? So I already labeled them. So this one over here is going to be north. This one's going to be south, east, and west. And so I already rewrote this here from the problem statement, and I also went ahead and redrew our graph, so how it would look like. So they tell us our dipole moment is in the positive x hat, so that's why it's going to be laying here flat on the x-axis. And so these are for polarized atoms, and this is north, south, west, east, as we know. And so with these, we can now draw our electric field lines of every polarized atom according to the dipole moment. So as we know, let me draw this over here, we know that this dipole is like this. And so electric field is opposite to the dipole moment. The dipole moment is from negative to positive in a dipole. So if it's opposite to that, so we're gonna do positive to negative, positive to negative, positive to negative, and so on. You know, this is how this, oh my goodness, I'm so sorry, electric field lines will look according to this dipole. So somewhere in here is this alpha particle. So let's say it's gonna be like over here, you know? And so as we know, it's gonna go this way, the electric field of that dipole, which is south. And the same for north. It's gonna be somewhere over here, and it's gonna go this way. Oh my goodness. Like that. So we draw them like that on our graph over this way. And these little guys, they are going this way because they are parallel to our dipole. So they're gonna go the same direction to the dipole moment. That's amazing. So we are taking in mind these formulas, but there's some things missing. So we have to calculate the dipole moment of each polarized atom to plug everything in this. And that's what the first questions ask us. To calculate it for north, south, east, west in terms of PD alpha K. And so we know that we don't have enough information for these. So what other formula is there? We know that there's P, oh no, I'm so sorry. Yeah, P is equal to alpha times E external. So we're gonna use this formula. I'm gonna go back to black. And so we're gonna calculate it for each one. So P N equals, we have to calculate it with these symbols. So we're gonna say alpha. And what electric field formula are we gonna use? We're gonna use the parallel one since it's parallel to our dipole. So we're gonna use parallel. No, not parallel, I'm so sorry, perpendicular. It's perpendicular to our dipole. So we're gonna use that. And so here, when we go here, for our formula for perpendicular dipole, this over here is gonna be our P times X hat, and this over here is gonna be D cubed. And this whole thing over here is gonna be K. So we're gonna take those in mind, and we're gonna say K times P times X hat over D cubed. But we also have to put in the direction it's gonna be. So like we take this guy over here and we look at this. It's going to the negative x hat direction. So we're gonna multiply it times the negative x hat direction. And so that's gonna be negative alpha k p over d cubed. Let me check this real quick. Yes. Oh goodness, so silly. Forgot to put this one. Okay, there we go. And now we see that these two electric field lines for north and south are the same thing. So we can imply that they're the same formula. So we're gonna say P n dipole moment north is equal to dipole moment south equal to the same formula. So negative alpha k p times x hat over d cubed. Okay, so now we got those two. Now we gotta calculate west and east. So let me highlight this. Oh, that's a terrible box, but it's okay. Okay, so we're gonna calculate P, let's say east first. So it's alpha times E external, but this one, since it's parallel to the line of the dipole, it's gotta be parallel formula. So alpha times, we look at this formula over here, it's just the perpendicular formula, but times 2. So it's gonna be K times 2 times P over d cubed. What is the x hat direction symbol? It's gonna be positive. So x hat, positive x hat. And so we know that P east is equal to P west. So we're gonna say they're both the same. So alpha times K times 2 P over d cubed times x. So perfect. Now we got everything we need from this problem. Okay, so that's our first question. Now we have that. And so this is our second question. So it says write an expression for the net electric field at origin. So net electric field is it's practically the summation of all our polarized atoms. So it's gonna be like this: E net equals E south plus E north plus E east plus E of west. So we're gonna calculate each of these, but these and this one and this one, they're both the same. So we can just go straight ahead to both of them. So ES, let's say since it's perpendicular to the line, we use this formula. So K times, we use the dipole moment we calculated over here, which is perfect. So we're gonna say, instead of plugging it in directly, we're just gonna say, oh, so sorry, PS over d cubed, yes. Okay, and then electric field of north is equal to electric field of south. I'm not gonna write it again, but you know what? I'm gonna write it again. It's okay. I'll be nice. And then electric field of east is equal to parallel formula, so 2 times P of E over D cubed. Oh my goodness, I forgot the K. See, these are the little mistakes I get you, but when you do these problems more calmly, you can see those mistakes. Okay, so now we have all of them. And this is the formula we're going to use. Okay, we're not going to move it. But, so E net is going to be equal to, so PE is the same thing as saying negative 2 P north. Since it has the negative and going on. Okay, So it's going to be negative 4 pn. Yeah, I'm sorry, I didn't make that clear. It's just what they did here when we write it out is E net is equal to this whole thing so they said E, these are the same, so 2en plus 2e right? And then they plugged everything in, and that's why they got another answer. But we have the same thing, we just needed to add the 2. We forgot that little detail, but it's okay, guys, it's okay, because this formula over here includes 2, so this is 2. Yeah, okay, so this is our thing. We're gonna calculate this, so it's gonna be negative 2k over d cubed. It's gonna be negative 5p. And so finally, oh my gosh, finally we can plug everything in. So 10k all over d cubed times dipole moment of north, which is alpha px alpha negative px hat. And that's our answer. That's our answer. Okay, that will be all for today. Thank you so much for watching.